Derek Rasmussen, and I am doing 10.2 independent and dependent events for EAP Math Period 5. Unit 10.2, independent and dependent events. So you're probably wondering, what's the difference between an independent and dependent event? An independent event is when the outcome of one event does not affect the outcome of the other. A dependent event is when the outcome of one event affects the outcome of the other. An example of an independent event would be dice. So one die does not affect the outcome of the other die. An example of a dependent event is a deck of cards. If you choose a card at random without replacement, the probability of picking the same suit decreases, while the probability of choosing any other card increases. So here's a core concept for independent events, and it just shows what it looks like with variables. Two events, A and B, are independent events if and only if the probability that both events occur is the product of the probabilities of the events. So you can see how P of A and B is PA times PB, and they're independent, so A doesn't affect B. For dependent events, it's a bit different. If two events, A and B, are dependent events, then the probability that both events occur is a product of the probability of the first event and the conditional probability of the second event given the first event. So the first event, probability A, P of A, affects probability of B, P of B. So you can see with the symbols, it looks a little bit different than the independent events. Now just a quick recap. Conditional probability is a probability that event B will occur given that event A has occurred. And it looks like P of B given A. And you find probability with favorable divided by the sample space or set of all possible outcomes. Independent means one outcome will not affect the other, while dependent means one outcome will affect the other. It's very important. Here's example 1. It says, as part of a board game, you need to spin the spinner, which is divided into equal parts. Find the probability that you get a 5 on your first spin and a number greater than 3 on your second spin. So I'm going to go to my paper and do the problem. So in this problem, let's call the probability of the spinner landing on 5 P of A, which we can write like this. And it would be 1/8, because the favorable outcome is 1 out of the total outcome, all the possibilities, which there are 8 numbers, so 8. And then the probability of it landing on a number greater than 3, we could write as P of B, which looks like this. And that would just be 5 over 8, with the same kind of rules where the favorable would be 5. There are 5 favorable outcomes over 8, which are all the different outcomes that can happen. So those are the two events, and we're trying to find out what is the probability that we get a 5 on the first spin, so that this happens, and number greater than 3 on the second spin. So these two events would be independent, because one event doesn't affect the other. So the way we can figure out the probability that we get a 5 on the first spin and then the number greater than 3 on the second spin, we can write it like this. And it's just pretty much saying the probability of A happening, and then times the probability of B, which is written like this.
And if you do the math, that equals 5 over 64, which is that as a fraction, but written as a percent would be around 7.8%.
So as we figured out, the event was independent, so probability of A, the first spin, didn't affect probability of B, the second spin. And we figured out the answer was 5 over 64, or about 7.8%. Now, here's example number 2. A purse contains 4 $5 bills, 5 $10 bills, and 3 $20 bills. 2 bills are selected without the first selection being replaced. Find the probability that one $5 bill is selected and another $5 bill is selected on your second grab without replacement.
So in this one, it's saying, what's the probability that you pull out a $5 bill and then you pull out another $5 bill? So the way we could write this is P of $5. And the probability of pulling out one $5 bill would be 4 out of 12, because there are 4 $5 bills out of 12, like all of the bills in there. And what we're trying to figure out is P of $5 after, that's supposed to be an A, $5. And that would be 3 over 11, because they had just taken $5 out, like a $5 bill out, which removes 1 from the total and 1 from all $5. So now what we're trying to figure out is what's the probability that you pull out one $5 bill, then without replacing it, which is important, and makes this event dependent. We would write it like this: P of $5, then $5. So once you pulled out a $5 bill, what's the probability that you pull out another $5 bill? And we could also write it like P of $5, which is up here, and then times P of $5 after $5, and that's up here. So when you plug in the numbers for these two variables, you get 4 over 12 times 3 over 11, and if you multiply them and simplify them, it's 1 over 11. And that written as a percent is about 9.09%.
Now that we figured out example 2, that the event is dependent because if you take something out and you don't replace it, then it will affect the outcome of the second event, the answer was 1 over 11. Or 9.09%. Now that we've done 2 examples together, I'd like you to take what we've learned and do example number 3. This one says a purse contains 4 $5 bills, 5 $10 bills, and 3 $20 bills. 2 bills are selected with the first selection being replaced. Find the probability that one $5 bill is selected and another $5 bill is selected on your second grab with replacement. So, if you did the problem, you might have figured out that the event is independent and the answer is 1 over 9, or about 11.1%.